In lesson 5.2, we are talking about techniques for evaluating limits. You always start by just plugging in your x value and see if direct substitution will work. So if I want to know what the y value of this function is at -1, which is what this is asking, you're just going to plug -1 in for the x values. So we're going to have -1 squared plus -1 minus 6. And here I'm getting +1, -1, minus 6, so we're going to get -6. We got a real number as an answer, so that is my limit. So it's pretty straightforward, just plug in your x value. Let's try plugging in -1 into this function. We have the exact same function on top, so instead of wasting time, I know the top is going to be -6. And then on the bottom, I've got -1 plus 3. So I'm getting -6 over 2, which is -3. Again, I got a number as an answer, so that is my limit. So that's the first technique. Just plug it in, see if you get a number. So on example 2, if I were to plug in -3, I see that there's a problem. If I plug in -3 like I did in example 1, here I'm getting 0 in the bottom. We can't equal 0 in the denominator. So what we can try to do is get rid of this problem. Get it so that it won't equal 0 in the bottom. So what we're going to do is we're going to start by factoring, because it looks like the top will factor. So if I find numbers that multiply to make -6 and add up to 1, I'm going to factor that into x plus 3, x minus 2. And then I want to cancel anything that would cancel. So those reduce, and I get it down to just x minus 2. And now I've gotten rid of the problem. I've gotten rid of the x plus 3, which was giving me 0 in the bottom. Now I don't have it anymore. So now I can try substituting again. So now I can try plugging in it again and see if I get an answer. So -3 minus 2, we get -5 as our answer, and so that is the limit. Let's look at B. If I try plugging in 1, I'm going to have 1 minus 1, which is 0, plus 1, which is 1, minus 1, which is 0, and you can't have 0. Can't equal 0. So we're going to try factoring this one. I'm going to factor this by grouping. So I'm going to group the first two, group the second two, and we're going to take out our greatest common factors. So on top I've got x minus 1. On the bottom, if I take an x squared out of these first two terms, then that would leave me with x minus 1. If I take a 1 out of those two terms, that leaves me with x minus 1. Those factors match. So that's one of your factors. And then x plus 1 is what's outside. And so that is your other factor. That's called factoring by grouping. And then we see that the x minus 1s on top and on bottom match, so they cancel out. And so I've got it factored down to 1 over x squared plus 1. So hopefully what I've done is I've gotten rid of the problem in the denominator where it's equaling 0. So to figure out if I've gotten rid of it, now we plug the 1 back in to our new equation and see. So we're going to substitute in 1 into the new equation that we've created, the new factored equation. And I end up getting 1/2. And so I got an answer. I didn't get 0 in the bottom, so that is my limit. Example 3. If I plug in 0, we see right away we're going to have 0 in the bottom. So we could try to factor, but if you look at this, I don't see any way to factor something like that. So we have to try something else. So another technique is if we've got square roots and fractions that are hard to deal with, you could multiply by the conjugate. So my first step is to multiply by the conjugate. And we've used the conjugate a lot, so hopefully you remember what I'm talking about. If we take the original function and take the complicated part and multiply by the conjugate of it. So the complicated part is the part with the square root in it. And the conjugate of that would be square root x plus 1 plus 1. You're just changing the b term into a different sign. Whatever you do to the top, you have to do to the bottom so that you are multiplying by 1 and keeping the fraction the same. And then we FOIL. So if you multiply those, the radicals cancel. If you multiply those, you have positive radical x plus 1. You multiply those, you have negative radical x plus 1. And you multiply your 1s, you have negative 1. Now, the bottom, you don't need to do anything. You can just leave it alone. I always leave the bottom alone. And then those cancel on top. We also have a 1 and a negative 1, which are going to cancel out on top. So I'm left with just x. And that x on top, since it's alone, it's going to cancel with the x on the bottom now. So really, there's nothing left on top. I've got it simplified down to 1 over square root x plus 1 plus 1. Now, hopefully, I've gotten rid of the problem where I can't get 0 in the denominator. So if I plug in 0, hopefully it'll work now. So now we go to substitution. Substitute in x equals 0. So we're going to have 1 over 0 plus 1 plus 1, which is 1 over rad 1 plus 1. We are getting 1/2 again. So the limit is 1/2 for example 3. In example 4, we see that if we plug in 0 to the exponent, we're going to have 0 in the denominator. So we can't do that. I don't see a way to factor something like this. I don't see any radicals that I could do conjugate with. So I'm kind of out of techniques. So what I could do is look at a graphing calculator or type this into Desmos and make a table for it. So I went ahead and did that. So I made a table. And I'm approaching 0. So that is my center number that I want to get closer to. And so that's what I'm looking for. I want to know what happens at 0. And so I did a number smaller than 0, which is close, negative 0.1. And then I did negative 0.01. I got closer. And then I did negative 0.001. And bigger than 0, I did 0.1. And I plugged in 0.01, which is closer, and then even closer, 0.001. So I plugged in those values, and I got 2.868, and then I got 2.732, then 2.7196, 2.7169, 2.7048, 2.5937. And if I'm looking from the left side, from the left, are numbers smaller than 0, this number is getting smaller, and it keeps getting closer to this 2.7 number. 2.71. On this side, from the right side, the numbers are increasing from 2.5 to 2.7. It's 2.7 again, so increasing towards 2.7. We could approximate this as 2.7 if you want. If you want an even better estimate, you can take your two numbers that you ended with and find the average value. So you could take these and find their average, add them and divide by 2, and I'm getting 2.71825. Which is unique because that is the number E. That is the Euler number. This is the equation for the Euler number, which is, I think, a cool problem. On B, same thing. We if we plug in 0, we're going to have 0 in the bottom. We can't let it equal 0. So we are going to have to do some sort of technique. It won't factor. It won't. There's no conjugate here. So we're just going to have to do a table of values and plug it into a calculator of some kind. So you can either go to Desmos or get a graphing calculator out. So I went ahead and typed that into a calculator. If you need me to show you in class, I can show you how to do this. And since x is approaching 0, I went ahead and made 0 my focus. So that's the center of my table, and I'm going to approach it from both sides, from numbers smaller than 0 and from numbers greater than 0. And so I chose a number that was smaller than 0 but pretty close, so I chose negative 0.1 again. And then I got closer, negative 0.01, and I got closer. So I'm zooming in on that 0. I'm getting closer and closer and closer and seeing what the numbers do. And then on the right side, or numbers greater than 0, I chose 0.1, 0.01, and 0.001, just like last time. And so when I typed that in, and I made sure it was in radians because it's got this x and not a theta, I got 0.998, and then 0.999, and then 1, and then nothing. And then here I got 1 and 0.999 and 0.998. And we see from the left, the numbers are getting larger towards 1, going towards 1. And from the right, the numbers are getting larger towards 1. And so my limit from both sides is 1.